This video is to describe the avionics box that I have built for my little turbine-powered helicopter. It mounts in the helicopter between the upper two airframe longerons, just above the engine, which is covered up with plastic there, and the fuel tanks. The front of the avionics box is the section there with the engine control unit, or ECU, sticking out in the front, which is the aluminum box that you see there with the red and blue plastic caps. To the left of the ECU are three firewall terminations made out of spun stainless steel, and that's where the wires will come and go to get to the electronics that are inside the box. Looking around the back, we have the little plastic gray assembly right here is a largely bug and moisture proof air vent. The two catches, obviously, the battery switch, which will allow selection of either the main two batteries or the auxiliary power, external power, which the connector for which is found underneath this black cover. The little antenna on the top is a transponder antenna, diversity antenna. The ship will have one on the bottom, which is the more normal location, but it'll have two so that it will comply with airspace requirements where diversity signal, that is signal that will go to a satellite, is required. I'll go ahead and open it up now. I used a lid stay made by it's marketed under the name of Lamb. It's made in Japan, very beautifully made lid stay. I found that originally it had too much it required too much friction. The torque required to operate it was too great for this lightweight lid, but I discovered that if I drilled out the center of this very precisely machined rivet, that I could put a number 8 screw through it, put a nut and a washer on it, and then vary the torque against the little black torque spring that you see in there to get the torque adjusted just right so that it is very easy to move and yet the lid stays wherever it's put. This is the glove box area for storing little things that I might need while I'm in flight, my lunch, a spare set of underwear, or whatever else I might need. The screws aren't in holding it down. The two aluminum, powder-coated aluminum straps along the outside I will remove right now so that you can see what the inside looks like. One thing that hasn't been done yet is that when this is completed, I will take a spare section of this silicone gasket material and cut off just the sealing bulb, and I will attach a length of it across this little bulkhead with some 3M VHB adhesive tape, and that will provide a real positive seal so that any little bits that might be in here won't be able to levitate over and down into the electronics section that is forward and below these little shelves. Okay, so I'll show you how that all comes out now. Of course, these would be screwed in, screws would be removed, little stays would come out, forward bulkhead comes out, gasket has to be removed. There's a little trick to getting this all out. And these are made from some honeycomb phenolic typical fiberglass skin aircraft structural panels. I'll stick the gasket back on. It'll slide back on now. And I'll show what's on the inside. The first thing is this EXT680C EarthX lithium battery. It's much larger than is necessary for its role. It is its purpose is to act as the backup power supply for the ECU. The ECU normally gets its power from the ship, but if the main bus goes down for any reason, then this battery, because of its size, would operate the ECU probably for a week without running out of power. The reason I selected this battery bigger than you really need for this particular application. This is the smallest of the EarthX batteries that comes with the integrated battery management system that has the warning feature. So that little lead there provides a fault signal to the instrument panel. So the back of the ECU, engine control unit, these are the firewall penetrations, the backside where the wires will come and go. This box is the MGL RDAC XF that I'm using. It takes analog signals from things like oil pressure, oil temperature, fuel level, fuel flow, and so on, and converts them to a digital signal that is then transmitted by a single pair of wires up to the EFIS system in the cockpit. This is a terminal module holder. This one has one terminal module in it. It will hold up to 4, and it will have all 4 in it when the ship is wired. These little terminal modules each one of these will act as a bus, a particular subsidiary power bus for various things that are powered on the ship. The aluminum strip that you see right here is an analog for what will be a copper ground bus that will be floating. It will not be electrically connected to the airframe. It will only connect at one point, which is at the engine block or the gear case block. This is just an analog for determining where the holes need to be drilled. It will be made out of copper, and it will sit on phenolic blocks to see that it floats electrically. Attached to the copper bus will be a number of these grounding terminal modules, and they will be attached by their own stud. When they're attached to the to the grounding bus, then each of the 12 connections that each one of these provides will be at the same electrical potential as the ground bus, and they will provide a very nice, neat, compact means of connecting all of the grounds for the various circuits, as well as the cable shields for those cables that are shielded. Sitting right next to it, this is the ECU's switch box, and it just takes signals coming from the ECU and changes them into a signal that the EFIS can understand to provide fault alerts for the ECU itself. This is vertical power Astronics primary power system, and with the primary power system, all the primary power connections are made in one spot. The battery, the alternator, the main bus output, and the starter output all connect to this device. Underneath this cap plug is a Cannon plug style circular mill connector that is where all of the signaling and control wires connect. This replaces battery relays, starter relays. It's all solid state with almost no idle current consumption when it's not actually switching something. Has very substantial MOSFETs inside it to do the switching. This is the back of the battery switch, obviously, the back of the external power connector. The connector is not installed there yet. I'll do that soon. This is a fourth of the firewall penetrations, and this is where the wire from the positive from the main batteries will come, and that will be 2 EXT 900s that will be paralleled. That's basically it. Again, that's the diversity antenna for the transponder, and it attaches to those Adele clamps with 3 on each side gussets, and there's a gusset on the inside and the outside. This is 50 thousandths material, 50 thousandths aluminum, and each of the gussets on both the inside and the outside is also 50 thousandths thick. So that's the avionics box of my little turbine-powered helicopter.